So we have come to this exercise problems. Right, the questions are here. Those who don't have textbook, you can look at the board. So we'll try. So determine whether, here they are not asking us to prove. Here we are asked to find whether they are reflexive, symmetric, or transitive. Right. So can you try the first one? Just tell me what I'm supposed to do. So what is your understanding? You can have a look at this. You have a relation RZA. So A contains how many elements? 14. The first 14 numbers from the natural numbers, right? So they are defining a relation. What is the relation? Those ordered as x comma y such that 3x minus y is equal to 0. Okay. So tell me the order. We'll go in the order. So only she is going to answer, right? If you get stuck, I'll tell you. For reflexive. For reflexive, what should I say? Is it going to be reflexive? So first of all, 3x minus y is equal to 0. Then what will happen? Y will be equal to 3x. Right? Means x comma y. Those two numbers in the ordered pair, where do they come from? Where do they come from? They come from either of the 14 numbers. Right? So if I put x is equal to 1. If I put x is equal to 1 here, I'm starting with this number. Right? So 1. What will the other number be according to the relation? Observe, observe. If I put x is equal to 1 here, 3. Right? So if I put 1, the next number is going to be 3. If I put 2,
6.
if I put 2, it will be 6. Meaning, for a given number, are you able to find the counterpart also the same number? Are you able to find 1 comma 1 here, 2 comma 2 here? Will you be able to find? Never. Right. Hence, it is
Not reflexive.
What about symmetry? What about symmetry? So for symmetry, what should happen? If one exists, the other should exist. Okay. Suppose I take 1 comma 3. So 1 comma 3 belongs to R. Is it right or wrong? Why? Because when you put x is equal to 1, you are getting y is equal to 3. It belongs to R. If this is belonging to R, Vishnu, you know your doubt period view, then what should happen? 3 comma 1 should belong to R. Whereas when I substitute 3 there, what do I get? 1 comma 3 belongs to R, but 3 comma 1 does not belong to R, hence symmetry is also lost. Right? Then what about transitive? So I have 1 comma 3 belongs to R, right? And 3 comma, observe this, 3 comma 9 belongs to R. When I substitute 9 in the place of x, what will I get? When I put 9 here, what will I get? I get 9 comma 27. This is possible. Why? Because 27 is not a part of the set itself. Both the elements in the ordered pair should come from the set. If I put 9, I get 27. So where should I actually stop this operation? See, I put
Till
1.
14.
Sorry? Divya, tell me.
Till 14, sir. Inside the elements.
14
Inside the set.
till 9k it's not working. 9 comma 27 is the 4 can endruma. Up 6. 7 can I have to stop. Oh, 3x, sorry, 2x. Okay. So 4 limit. So you have to stop the 4. So what will be the relation? 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. When I substitute 5, I get 15. But what should happen? Both these numbers belong to this set, no? They come from this set. So I cannot substitute. So what is that you are able to understand? 1 comma 3 belongs to R, 3 comma 9 belongs to R. Obviously, 1 comma 9 does not belong to R. It is failing here also. So you have to write the answer as this neither reflexive nor symmetric or transitive. It is neither of them. Simple. You're able to understand this. Right? Only thing is you need to concentrate in this way. Right? So you guys want to make a quick note of it, please do it. Shall I proceed to the next one? Yeah. So can I erase this? Everybody?
Yes, sir.
Hariharan, now you try the next one. Yeah. So second question says there is a relation in the set of natural numbers. Means they have given you the set of natural numbers. From this, you are supposed to form a relation such that how are the ordered pairs related? There is an ordered pair x comma y, both come from the natural numbers, right? In such a way that y is equal to x plus 5 and x is less than 2. Meaning of this. So for it to be reflexive. So what is the first number with which I'll start my trial? Natural number, where does it start with? 1. Hariharan, tell me. If I substitute 1 here, what will be the value of y? 6. If I substitute 2, if I substitute 3, if I substitute 4, you should not substitute. Because they told x is less than 4. Okay. So don't do that. So you take only these three, is it reflexive? Obviously. So what about transitive? Sorry, symmetric. It's not symmetric. So if I have 1 comma 6 belongs to R, but 6 comma 1 you can never find it does not belong to R because they say the input value itself could be less than 4. Right? What about transitive? Hariharan, tell me. I'm not able to hear. Why? How will you write it? 1 comma. So first of all, you don't have any numbers. It's not transitive also. Why? Okay, it is a special case. Okay, why is it? So this one hold it, I'll tell you after something. Why is it transitive? Because you don't have the counterparts. Okay, I'll tell you about that later. Do the next one. A relation R in set A given as 1, 2, 3, 4, 5, 6 as x comma y, where y is divisible by x. Hariraghav. Try that. Hariraghav. So the set A contains 6 elements. So out of those 6 elements, how was the order pair supposed to be? So y is divisible by x. So how will you take the numbers? So is it reflexive? Can you take, if I take 1 here, I need to choose a number y which is divisible by this one. Can I think of 1 comma 1? Because the number is divisible by itself. Then what about 2 comma 2? Till where? I can take it till 6 comma 6. So everything belongs to R. Reflex. What about symmetric? What about symmetric? So why? If I take 1 comma 2, that belongs to R. Is it right? So 2 is divisible by 1. But what is that you cannot find? 1 is not divisible by 2. Does not belong to R. Hence it is not symmetric. What about transitive? Is it? So 1 comma 2 belongs to R. Then 2 comma 4 belongs to R implies
1 comma 4 is also
all it has
symmetric.
right. See, there is a better way of, instead of taking the number, there is a better way to think of it. But as I told you, initially we'll start with this. After a point, we'll take it. So can you try the next one also? Next one is very simple. What is the answer? Last one. The relation R is set of all integers defined as R is equal to x comma y such that x minus y is an integer. Meaning. Yeah. So how are you going to think? I'm concerned about the thought process. Answer is right. It's equivalence. But how will you prove that? So if I take x comma y, both the numbers are supposed to be integers. The difference between an integer, the difference between two integers is integer. If you take any number 1, 2, 1 minus 2 is minus 1, it's an integer, right? Similarly, if I find 1 comma 2, right? If I find 1 comma 2 that belongs to R, then I can also say 2 comma 1 also belongs to R. Makes sense? Makes sense, right? Similarly, what about the other case? 1 comma 2 belongs to R. 2 comma 3 belongs to R, implies 1 comma 3 also belongs to R, because how are the numbers in the ordered pair chosen? 1 minus 2. 1 is an integer, 2 is an integer. So 1 minus 2 is an integer. 2 minus 3 is an integer. 1 minus 3 is also an integer. Hence it is equal. Right?